Hello everyone. Here we are going to present our work estimating image depth in the comics domain. Our models and data can be found at the link given here. First off, allow me to convince you that why is our work relevant? Depth estimation in the domain of comics is a very challenging problem due to the occlusions between characters, unusual object sizes, unusual perspective views, and different illustration styles by artists. Further, if we are to employ a state-of-the-art depth estimation model to comics images, as shown below, we do not get accurate depth outputs. This is because the employed depth models were trained on real-world images, and hence they do not generalize well to the comics domain. Additionally, comics are a physically restricted domain with noisy and sparse settings. Further, the images are monocular and they lack any ground truth depth annotations. To that end, we leverage ground truth from the real-world image domain. How do we do this? In our method, we can see the depth results of employing a state-of-the-art depth estimator trained on real-world images in two scenarios. One, where the model is applied to a comics image directly, and another, where the model is applied to a translated image from comics to the real domain. From the results, we see that the translation benefits the depth estimation. We therefore use an off-the-shelf, unsupervised image-to-image translation method to translate the comics image to natural ones, and then use an attention-guided monocular depth estimator to predict their depth. This lets us leverage the ground truth depth annotations of existing natural images to train the depth estimator. Specifically, our depth estimation module is on encoder and a decoder model with skip connections in between the encoder and decoder layers. These skip connection layers model the local context in between the visual features by taking the channel and spatial attention. These attention modules are inspired by the state-of-the-art contextual depth estimator model, where the GCM or the global context module models the context of the entire scene, whereby it computes the spatial and channel attention between the objects in the global image, shown above. To complement the GCM, we use the local context module that processes the features extracted at different encoder layers. Moreover, to clearly contrast the edge boundaries of the objects, we incorporate a Laplacian edge detector to the spatial branch of the local context module. When the comics are translated to the real domain, the translated images comprise text areas or speech balloons, which are in turn unknown to depth estimators trained on real domain. This leads to text-based artifacts in the depth results, as the depth estimator considers such text areas as objects. Therefore, to control the position of the text areas in the translated images, we train a unit in a supervised manner. We mask the depth maps by multiplying them pixel-wise with the complement of the text area masks before using the L1 loss between the masked pseudo-ground truth depth and the depth predictions. We show qualitative results where our method outperforms both the baselines and provides a better foreground versus background separation. We also introduce a benchmark dataset for comics images with 450 manually annotated image depth pairs comprising 300 images from the standard DCM validation dataset and 150 images from the standard eBDtheque validation dataset. Quantitatively, our method outperforms all the other baselines across two sets of benchmark images across all metrics. Our method can be further extended to perform comics reconfiguration or retargeting of comics panels. In summary, we introduce a cross-domain depth estimation method by leveraging an unsupervised I-to-I translation method. We exploit the contextual information for depth prediction of a given scene using an inner feature-based CAN and a Laplacian edge detector. By introducing a text detector, we reduce the artifacts from text and speech balloons in the depth predictions, which are specific to comics. We introduce a benchmark dataset for comics images with 450 manually annotated image depth pairs, which can be used as a benchmark for future papers for depth evaluations. Thank you.